What's going on, y'all? Sean, the Master about Tutoring here, and I am doing this video over simplifying radical expressions, something that you would talk about in Algebra 1. Make sure you like and subscribe. Also, I'm not going in depth with the definitions. We're just kind of going right into simplifying some radical expressions, and I will kind of do some brief defining along the way. But I have another video you may want to look at if you want to kind of get a little bit more background into what radicals are and some of the intricacies and whatnot. So anyhow, let's go ahead and get right into this. All right. So we have three expressions that I'm going to simplify here. Square root of 32, cube root of 128, and then negative 7xy times the square root of 45x cubed y to the fifth. Now, when you simplify a radical expression, that implies that you have a radical expression that can be simplified. And the main thing you want to really keep in mind is when you're taking the nth root of something, whether it be the square root like this first one here, or the cube root, or whatever it is, under the bracket, you're wanting to see if you have three of a factor of a number. So, for example, 8, but not three, but in number of a factor of a particular number you're taking the root of. What I mean is, for example, if you're taking the square root of 4, you're asking yourself, are there two of any factor of a number underneath that bracket that I can take out as um one root of that particular number? So in other words, the square root of 4 is 2 because there are two twos, two factors of 2 underneath the bracket for that number 4. So you can take you take one of those out to the outside and it becomes just a 2 as the square root. You multiply that times itself to get 4. It'll make more sense when we do it here. All right, so square root of 32. The first thing I want to do, because this is not like a clean, like a perfect square, meaning it's not just like a number that you can multiply by itself to get 32. But we can simplify it first by breaking this into factors, and we're going to do that underneath the bracket. So 32 I know is going to be 8 times 4. Okay. Now, I can take the square root of 4. It'll be 2 on the outside with the 8 still on the inside. But I also know that there's something else that I can break down underneath. I mean, not underneath, but with the 8. So before we do any square rooting, for lack of better words, let's kind of break this into more factors. 8 is going to be 2 times 4 times 4. Now look at this. We're taking the square root. In other words, we know there's it's the nth root, the second root, which means we're asking ourselves, is there anything underneath the bracket where it's two of them that can come out as one of them? You know, a factor that can be multiplied by itself to get whatever number. And so we have two fours that can come out as one four. So that becomes 4 times the square root of 2 as a final answer. Okay. Now, the second example here, we have the cubed root of 128. In other words, we want to see, is there a number that we can multiply 3 times, some factor that we can multiply 3 times to get 128. So let's start again by breaking up this number underneath the radical. So I know that 128 is going to be, let me see, that's 4 times 32. Yeah, 4 times 32. I don't see 3 of anything underneath yet, but I'm sure I will. Let's break it down a little further. 4 times 4 times 8. Let's go a little further because 8 can be broken into factors. I mean, the 4s can as well, but you'll see why I'm not breaking them down. 4 times 4 times 4 times 2. All right, there you go. You got 3 4s. We're looking to see if we have 3 of anything because our index is 3. So we can, because we have 3 underneath, we can take those out as 1 4. So that becomes 4 times the cube root of 2. Okay, hopefully you see what's going on here. All right, one with variables, negative 7xy times the square root of 45x cubed y to the fifth. I'm going to do this step by step so it's very clear. First, let's deal with this number underneath here. So this is going to be negative 7xy times 45 is 9 times 5. Then you have x cubed y to the fifth. Is there anything we can take the square root of under here? Well, let's deal with the number first because we can do that with these variables as well. We can take the square root of 9, which is 3. So that's going to be, that comes out as a 3 on the outside. 7 times negative, I mean, negative 7 times 3 is negative 21xy. And then now underneath we have 5 um, x cubed y to the fifth. Okay. Now we're going to break up these variables into their factors. I'm going to do the x first. So that becomes negative 21xy times 5x cubed is, that's x times x times x, and then times y to the fifth. Remember, we're taking the square root, the second root. So if we have 2 of anything underneath, we can take 2 of them out. So we have 2 x's underneath. We're taking the square root. So 2 of those come out as 1. So then this becomes negative 21. X times the x that you pull out is x squared y. Underneath the bracket, now we have 5. There's a remaining x. Now y to the fifth, I'm going to expand that. Y times y times y times y times y. Okay. Now, once you get the hang of this, you won't have to like expand it so much. But how many groups of 2 y's do we have? We have these 2, then we have these 2. So this will come out as a y. This will also come out as a y. Sorry, I'm kind of writing kind of scrunched up. So that's negative 21 x squared, and then the y times the y we pulled out times the other y we pulled out is going to be y cubed, and then times the square root of 5xy. That's what remains, and that is our answer. All right, so remember, whatever the index of the radical is, that tells you how many you need to have underneath that radical bracket to be able to pull one of those factors out, if that makes sense. So let's go on to another example. Okay, let's check out this more involved radical expression that's going to call on a few more skills and just remembrances, so to speak. So anyway, let's get into it. So you got 5xy over z squared times the square root of 3z to the fourth power over 5xy squared. Okay, now, so we got a lot of things going on here, but this is what I want to highlight. Okay, so as it pertains to this 5xy over z squared on the outside, just kind of let that be for now. That's being multiplied by the radical. Now, underneath the radical, the same stuff applies. You want to try to make sure that you pull out anything that there are 2 of. Like z to the fourth power, that's 2 z squares. Okay, so that's going to come out as a z squared. And then y squared, keep in mind that y squared, that's a 1 over y squared underneath. So that can come out as a 1 over y. So let's do that in the next step. I'm going to do my work here on the left side. So 5xy over z squared. Now, that z to the fourth power comes out as a z squared, and then that leaves 3 over 5xy squared underneath. Okay? Now let's keep on going. So that 1 over y squared is going to come out as a 1 over y. So that ends up being 5xy z squared over z squared y, because that y came out as a 1 over y, and then that's times 3 over 5x. Okay, now check this out. You got a z squared on top, z squared on the bottom. Those divide to 1, so they effectively go away. You have a y on the top and you have a y on the bottom. Those go away, leaving just 5x. So now what you have is 5x times 3 over 5x, the square root of 3 over 5x. Now, keep this in mind too. Here's a rule to remember. Whenever you have, how do I want to express this? So if you had a square root of a to the n, oh no, I didn't want to write it like that. If you have the square root of a divided by b, that is the same thing as the square root of each of those separately. I mean, not the square root, but the nth root. Sorry. I'm going to circle this because that's like a tip that you need to remember. And so I'm going to actually use that to rewrite what so far is our answer. So that's 5x times the square root of 3 over the square root of 5x. Now, if you remember, we don't like to have radicals in our denominator. So the way that we get rid of those is by rationalizing the denominator. In other words, by multiplying the fraction by the same thing on the bottom, and then of course whatever you do to the bottom, you have to do to the top. So what happens is that becomes um which brings something else to mind. If you have the square root of a, I mean not the square root, the nth root of a times the nth root of b, that's the same thing as the nth root of ab underneath. Okay? So that's going to apply up top. So you have 5x times, and I'm just going to add all the steps, 3 times 5x. They're the same index, so that's why you can kind of combine them underneath like that. And then the square root of 5x times the square root of 5x is just 5x. These go away to 1. So your final answer is going to be the square root of 15x. So you see how, oh yeah, let me go ahead and, so this is the product rule. And this is the quotient rule. Okay. But you see how we got from here to here. That's the simplified version of the same thing. Okay. So just take your time. These actually can be kind of fun in a sense. Just take your time and kind of see everything that you're working with, and simplifying radical expressions is not that bad. Okay. Let me know if this has been helpful for you. If you want me to record another video that kind of explores some other particular radical expressions, just let me know in the comments. Make sure you like and subscribe if you haven't already, and have a good one. Hey, thank you for watching this video. If you need math tutoring or you need SAT math help, look in the description to find out how you can sign up today. Also, don't forget to like, share, and subscribe so you stay in touch with Math Swap Tutoring on YouTube. Have a good one.